Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will look at the spanning tree, one of the most important algorithm called as Prince algorithm. Let us begin with the topic. I have defined a class named as Prince. Inside that, I have defined an array called as unsettled. Now it is very important to know the return type of the array. You must remember in this case we have the return type as Boolean. So what do you mean by Boolean? It is going to return me as either true or either false. So one of the value will be coming up as the return type, that is true or false. In similar pattern, I have another set of array called as settle with the same return type called as Boolean, whose access specifier are very important. These are the access specifier. Both are going to be private. Now we look at another set of variables. We have number of vertices, then we have the adjacency matrix. Since we are using the concept of adjacency matrix memory representation of the graph to represent the Prince algorithm. In case of adjacency matrix, the matrix consists of rows and columns. So we have adjacency matrix with rows and columns. Then we have another array called as key to store the key set of vertex. Then in these cases, we need to find out whether the vertex is reachable from the given set of vertex. That is, whether the vertex under consideration is reachable from the source vertex. If it is not reachable, we are going to use the value called as 999 to indicate that it is infinitely distance. So we write down public static final infinite variable of the type integer with the value 999. 999 indicates it's a unreachable. Then we have another array called as parent. These are the set of values we need to define first. This consists of set of arrays and few set of variable. Now we'll go for the constructor of the class. We write down public Prince constructor with the parameter number of vertices. Now we will pass on this value. We have this dot number of vertices. To pass this value, we have this dot number of vertices equal to number of vertices. So number of vertices are taken from the user and passed on to the variable called as number of vertices using this reference. So we write down this dot number of vertices equal to number of vertices. When this is done, then we need to define the size of the arrays we have declared. Let us begin by one. We have unsettled equal to new Boolean number of vertices which is taken from the user plus 1. So unsettled arrays created of the type Boolean with the size as number of vertices plus 1. In similar pattern, we have settled equal to new Boolean number of vertices plus 1. Now we will go for the size of the adjacency matrix. The matrix consists of rows and columns. So we write down adjacency matrix equal to new int number of vertices plus 1. This is going to act for the rows, and number of vertices plus 1. This is going to act for the columns. When this is done, in similar pattern, we are going to define the values for the key and parent array. We write down key equal to new int number of vertices plus 1. So this will be the size of the key array. In similar pattern, we have parent equal to new int number of vertices plus 1. So we have defined with the set of arrays and its set of size. So up till now, we have defined with the set of arrays which are needed to calculate the Prince algorithm value. Now we will define the functions to get the count. It is very important to have the count. Let us begin with the topic. We write down public int get unsettled count. As the function name suggests, we are going to try to get the unsettled vertices count. So we write down the function as get unsettled count with the parameter as Boolean unsettled array. So we have the unsettled array of the return type Boolean. Then we write down the count variable value as count equal to 0. So our starting value is going to be 0. Then we once add the variables, that is once we start counting, it will be added to the count variable. Let's take example, count value is 1. So how it is going to be calculated as count equal to count plus 1. Previous value of count is 0. Now we add 1. so it becomes 0 plus 1. So now the value of count is 1. Like this we are going to add the value. Let us begin. We have for int index equal to 0, index should be less than unsettled array dot length. We have defined the unsettled array. We are going to calculate its length and index has to be less than this value. Then we go with the checking. We write down if unsettled with the index value starting from the 0. Whatever value of this comes out to be a true value because we have the return type as boolean. So once this comes out to be true, then we increment the value of variable called as count by writing count plus plus. Once this set of values are done, this function will return the count variable value. We write down return count. Let's go for the another set of function. We have function called as Prince algorithm. As the name suggests, it is the logic of the Prince algorithm which we are going to write into this particular function. Since we are going to use the adjacency matrix concept, the parameter passed to this function is going to be adjacency matrix. We write down the function public void Prince algorithm with the parameter int adjacency matrix. This is the array. Then we write down the another set of variable called as evaluation vertex. Once this is taken, then we will start with the source. Now in our case, we are going to start with the source as 1. So we write down for int source equal to 1, source less than equal to number of vertices. This number of vertices are defined by the user. Once this is done, we have already found out the source. Now we need to find out the destination. For this, we are going to write down for int destination equal to 1, destination also less than equal to number of vertices. So both source and destination has to be less than number of vertices. Once this is taken up, then we need to pass on this value to the adjacency matrix by using the reference of this. So we write down this dot adjacency matrix with the parameter as source. So source will act for the rows and destination, this will act for the columns. And we take the value as adjacency matrix source destination. So source destination address of the adjacency matrix is passed to the adjacency matrix taken from the adjacency matrix of the user. This is how you transfer the value of the adjacency matrix source and destination taken from the user to the particular reference array called as adjacency matrix with the particular set of source and destination. We write down for int index equal to 1, index less than equal to number of vertices. If this is less than number of vertices index, then we need to transfer the value of infinite which we have taken as 999, indicating that it is unreachable, to the keys. We write down key index, that is the index number taken, equal to infinite. So this value is what? 999. So key index is going to be 999, indicating that it is unreachable. If this condition doesn't hold true, then we have another set of values. We write down key 1 equal to 0. Unsettled 1 index is true and parent index number 1 is going to be having value as 1. This is to get the set of values. Now we will check with the while condition. We have while get unsettled count which we have defined with the parameter unsettled not equal to 0. It means there are some node to be calculated, or I can say some vertices that needs to be visited. While this condition is true, we are going to go for the algorithm. We write down evaluation of vertex equal to, we call a function called as get minimum key vertex from the unsettled. As the name suggests, we are trying to get the key value vertex from the unsettled which is of the type minimum. So we have the function as get minimum key vertex from the unsettled. So obviously we are going to pass the parameter as unsettled. When this is done, we are going to define the another set of values. You must remember we have defined the return type of unsettled and other variables array as boolean. So we need to have the value in true and false format only. That's why we write down unsettled with the index as evaluation vertex equal to false and settled evaluation vertex equal to true. When this is done, that is we have done with the settled and unsettled array, we need to call the function for evaluation of the neighbors. We write down evaluate neighbors with the parameter as evaluation vertex. So evaluation of the vertex is taken this value and then passed to the function called as evaluate neighbors. As the name suggests, we are going to evaluate the neighbors. Neighbors are the next set of vertices near from the given set of vertex under consideration. We have done with the basic set of functions of the given program. Now we will calculate the minimum key vertex from the unsettled. Unsettled is your array which we have defined previously. Let us look at the function. We have private int get minimum key vertex from unsettled. Now this value is going to be unsettled to with array of the return type boolean. Once this is done, then we need to calculate the minimum spanning tree value. So we defined a variable called as min with the value as integer dot max value. We have int min equal to integer dot max value. So this value is taken and given to the variable called as min. Then we are starting with the node. So we keep its value as node. We write down node equal to 0. When this is done, then we go for the variable called as vertex. We have for int vertex equal to 1, vertex less than equal to number of vertices. If this is true, then only we go for checking of the unsettled vertices. That is the vertices which we have not till visited. That needs to be visited and get the minimum key value from this set of unsettled vertices. We have if unsettled vertex is equal to true. So we have the vertex value parameter of the array unsettled. So we write down if unsettled vertex equal to true and key vertex is also less than mean. So it means we need to have the minimum value. For this, first we need to transfer the value of vertex to the given set of node. The value of node we have defined it as 0. We take the value of vertex and transfer this set of value of the vertex to the node, and then we calculate the mean. We write down node equal to vertex. So value of vertex is transferred to the node. Then we have mean variable value, which value was previously as integer dot max value. Now we are going to take the key array value with the index as vertex. Key vertex, this value is going to be transferred to the variable mean. Hence we have calculated the value of particular node and try to get the minimum value of the key vertex from the given unsettled node. Once this is done, then we need to transfer the value of node. That is, we need to return the value of node to the given set of calling function. So we write the return node. Once this set of functions are done, we have done with the evaluation of the particular node only. Now we will write down the function to evaluate the another set of vertices that we called it as neighbor. Hence we write down the function name as evaluate neighbors. We write down public void evaluate neighbors with the parameter evaluation vertex. Once this is taken, then we go for the destination vertex. We write down for int destination vertex equal to 1 and it is less than number of vertices. Now we will calculate the condition for the settled. We have already done with the condition for the unsettled in the previous function. Now we will go for the settled values. We write down if settled destination vertex is equal to false, it means we need to visit this vertex. So we write down settled destination vertex equal to false. If this comes out to be true, then only we go for the evaluation of the adjacency matrix. We write down if adjacency matrix with the row defined by the evaluation vertex and the column defined by the destination vertex not equal to infinite. Infinite value is 999. So it means it is not infinite. It means it is still reachable. Then only we can calculate that particular part. If adjacency matrix, evaluation vertex and destination vertex is still less than the key vertex destination, still it is less than, then only we can calculate. If it is greater than, we have already done with the previous set of function. So we have key destination vertex value. This vertex value is going to be adjacency matrix with the particular row and column. So we are going to find out the cell number by writing adjacency matrix particular evaluation vertex, that is going to define the row and this is going to define the column. This is going to be transferred to the key array with the particular index number as destination vertex. Once this is done, then we need to transfer the value of evaluation vertex to the parent array. We write down parent array with the index as destination vertex. So our evaluation vertex value is now transferred to the parent destination vertex. When this is done, then we need to make sure the unsettled array is going to be true. So we write down unsettled with the index as destination vertex equal to true. Previously it was false. So we are going to make it as compulsorily true by writing unsettled destination vertex equal to true. This is how you evaluate the neighbors by taking the evaluation vertex for the calculation. It is very important to have the set of conditions predefined to check whether the value of the vertex is settled or unsettled. We have defined the all set of functions which are needed to evaluate the vertex, calculate the logic of Prince algorithm, but we have not defined the function to print that particular spanning tree. So now we are going to write down the function to print the minimum spanning tree. We write down system.out.println. We take the source and destination and vertex. For this we are going to start with the vertex number 2. Vertex less than equal to number of vertices. Now vertex has to be start from 2 because first vertex is going to be always 1. We start with second vertex to have the destination. So we have index vertex equal to 2, vertex less than equal to number of vertices. Then we call the parent vertex that will act for the source. Then we call the vertex which will act for the destination, and weight is going to be called as adjacency matrix. With the row number of the parent we have parent vertex comma vertex. So this will define the weight. Like this we are going to calculate the spanning tree with the minimum set of value using the concept of Prince algorithm. This is how you define the function to print the minimum spanning tree. Now we will go for the main function of the class with the concept of try-catch block. We write down adjacency matrix with the rows and columns. Then we have number of vertices. We take the scanner class objects called as scan to take the value from the user. Then we put our code into the try-catch block. Let us begin. We have asked the user to enter the number of vertices. So we pass this value to the variable called as number of vertices. Once this is done, our adjacency matrix rows and size of the columns and rows is going to be number of vertices plus 1. So we write down adjacency matrix equal to new integer number of vertices plus 1. This will go for the rows, and number of vertices plus 1. This will go for the column. So we have defined the number of vertices to be taken from the user. That value is transferred to the variable called as number of vertices. Then we have the adjacency matrix defined as the rows and column with the value of row greater, or we can say number of vertices plus 1, and column also number of vertices plus 1. Once we are done with this set of value, that is we have defined the adjacency matrix, we have defined the number of vertices. Now we need to calculate the value for the weight of the graph, or in other terms I can say the weight of the edges. This value has to be taken from the user. Hence we write down for int I equal to 1 to get the row, and to get the column j equal to 1 less than the value of number of vertices. We have adjacency matrix of particular cell as I j equal to scan dot next int. That is the value is taken from the user and passed to the particular cell number. Then we check with the adjacency matrix value. We have if I equal to j, it means value of adjacency matrix is going to be 0. If adjacency matrix is going to be 0, then we have its value is infinite. It means that is not reachable. Once we are done with the source, destination vertices and the weight of the graph, now we need to create the object of the class and call the particular set of function to perform the Prince algorithm. Let us begin with the logic. We have Prince equal to new Prince with the parameter number of vertices. So object is created with the parameter of number of vertices. Then we call the particular function, that is Prince algorithm. Now the parameter of this is going to be your adjacency matrix. Once we are done with the Prince algorithm, we need to print the minimum spanning tree. We have written the logic for the minimum spanning tree into the function called as print mst. We call prince.print mst. So we are done with the try block. Now we need to handle the catch block. The common error which occurs in the catch block is the user enters wrong input format. So we need to handle the exception call for the input mismatch format, informing the user that he has entered the wrong format for the either source, destination or the weight of the graph. This is how you calculate the Prince algorithm. Basically, Prince algorithm is used to calculate the minimum spanning tree. Thanks for watching this video. Please subscribe to Ekeeda channel.